projectile. It is fired at a speed of 50 meters per second at an angle of 60 degrees to the horizontal. So let's have a look here. This component is 50 cos 60, and this component here is 50 sine 60. So if we're looking at the maximum height, we only need to look in the y direction, the vertical. So vertically, u, v, a, t, s. The u is 50 sine 60 at its maximum height, that is a 0. That is minus g, or minus 9.81. T, we don't know, and that's what we're looking for. And for part B, we're looking for the s. So we'll go with v equals u plus a t. So the t is 50 sine 60 over g. Hey!
Oh, I thought you were talking.
Yes, I'm making videos.
Ah.
I saw her a few minutes ago. She was downstairs, and I thought she just replied to my email, but I assume she was in her office. Okay. Okay, so sine 60 divided by 9.81, 4.42, let's say. 4.42 seconds is the answer for the time. And then now for the s, we'll go with s equals ut plus a half at squared. So let me see, that is 50 sine 60 times 4.42 minus 4.905, that's a half g, and then t squared. So let's see, that's 50 sine 60 multiplied by the time minus 4.905 multiplied by the time squared. That comes in at 95.57 meters. Okay. Right, so that was A, B. Now C is the time of flight. So that's how long it takes the projectile to reach here. So again, we're looking at the vertical. But what's different now is the UVATS. So the U is still 50 sine 60. The V we don't know. The A is minus G. The T we don't know. But S is 0 because vertically it's still on the ground. So it hasn't been displaced. Well, finally hasn't been displaced from the ground. So let's see, we're looking for the time of flight. So we'll go with S equals U T plus half a T squared, and we'll not include 0 as an answer for T. T should be a positive number. So I can divide everything by T, and I get 50 sine 60 equals a half GT. So T is 100 sine 60 over G. Which is 8.83 seconds. Okay, what is the range? So that now means we have to look horizontally. So in the horizontal direction, it's just distance, speed, time triangle. That is all we need because there's no acceleration horizontally. So the range is the distance traveled horizontally, which will be the horizontal speed multiplied by the time. So multiplying our previous answer by 50 cos 60. And we get 221 meters, we'll say. What is the final velocity of the projectile just prior to impact? Okay. So horizontally, the final speed horizontally is the same as the initial speed horizontally because there's no acceleration, and that we just said is 50 cos 60. But vertically, we have to do a UVATS. U is 50 sine 60, V is what we want, A is minus G, and T is our time of flight that we had earlier, which was, what was it, 8.83 seconds, and the F is 0, and we're looking for the V, so we can just go with V squared equals U squared plus 2A S. It cancels, so you get V equals plus or minus 50 sine 60, because of the root we actually have a plus or minus. The plus answer corresponds to the initial value, so it must be the minus answer here because it's heading down. So we have V equals minus 50 sine 60, so that's Vy. So what is the final velocity? So the answer is 50 cos 60 along x in meters per second, and then minus 50 sine 60 along y in meters per second. Okay, which we can just hit in on the calculator. And what is the final speed? So it's heading like this at the end of the flight. Just before impact, it has 50 cos 60 this way and 50 sine 60 this way. So the speed is square root 50 cos 60 squared plus 50 sine 60 squared. No need to worry about the minus. 50 cos 60 squared plus 50 sine 60. Okay, 50 cos 60 squared plus 50 sine 60 squared, square root, 50 meters per second is the speed at impact, the final speed just prior to the impact. That's how fast it's going when it hits the ground at the end.